All right, next up, I'm going to show you how to solve the ALEKS problem. Classify the start material as intermediate, acid, base, and nucleophile, electrophile. Classify the mechanistic steps, and then it's going to want us to draw the mechanisms for part 3 and 4 of exactly how it took place. Simple rules that I have for this question is if you need to go back and refresh yourself on acid and bases or nucleophiles, electrophiles from my previous video. And then my rules overall is focus on the products on the right to determine what happened. One side will be the proton reaction side, and then the other will be the nucleophile electrophile reaction side. And then when drawing the mechanisms for the nucleophile electrophile reaction, it usually only gonna have one versus the proton transfer reaction side, which is gonna have two. And you'll see what I mean as I go through. So okay, it's going to show us kind of four elements or compounds, A, B, C, and D. And what it wants us to do is label them as acid, base, nucleophile, electrophile. And then my pro tip for this is I look at the products on the far side to see if I could identify a acid or a base here, which I identify acid right here with, which is hydronium. And I think which step is hydronium created in. And so what I look for is I see a H2O right here. And I know that for hydronium to form that it needs to pull another hydrogen in. And so I can't do this in this stuff right here. So I could immediately think to myself that, okay, this H2O is going to pull this in. So this is going to be my acid and base side. So I'm gonna go ahead and transfer it. So I'm gonna think like, all right, this is my base for D. And so that means right here, this has to be my acid. And next up, I look at the other side, and now I'm looking for electrophile and nucleophiles. From previous videos, as I said, nucleophiles will have the lone pair and like to form the bond. So you can look at what steps took place to create this mechanism right here. And so I'm going to see that B, because it has the lone pairs, is going to be my nucleophile. And that leaves A last as my electrophile. Next up, what ALEKS is asking us to do is to classify the reactions for each, and I'll just draw it here. So reaction 1, we see that it's a electrophile and nucleophile. So I'll just write it right here. So that'll be the nucleophile reaction. So sorry if my scribbling is kind of messed up on here. And then by process of elimination, because you're only going to have two choices, which is the nucleophile electrophile reaction. So the other is going to be the proton transfer. And that's where the acid and bases are created. So right here, I'll just write proton reaction. Really, you'll see proton transfer reaction, but I'll just leave it at proton reaction. And then the last thing ALEKS wants us to do is going to be to draw the mechanisms of exactly what took place. So we see that it says that for part 3, and kind of we've identified the steps of what happened earlier up here. So we know that this is the nucleophile electrophile transfer. And then my rule up here, it says that it's usually only going to be one mechanism that take place, which is going to be this oxygen with its lone pairs of electron is going to attach on right here to this carbon. And as you can see, like right here on the product itself, the side right here pretty much tells you what happened. So this oxygen ended up just pulling in and bonding right here. So that's that. And then at the end, the proton transfer side, as I said, it's usually going to involve two steps, which is going to be the base in your acid. So you're going to start at your base and you're going to draw a mechanism to where it's going to take one of them one of those hydrogens away from the acid. So that's going to be part one, where it pulls the hydrogen, and that's how the hydronium is formed right here. And then on the second part of it, it's going to show that this bond that held oxygen and hydrogen together, this is going to go back to the oxygen, as you can see here, or as you can see back here, because now you have, or I should say right here, because instead of 2 lone pairs on this oxygen, you now have 4. And that's pretty much how you solve the problem. If this helped you or any of your classmates, feel free as always to like, share, and subscribe to the channel. Thank you.